Okay, so arc length is the last part of section 6-3 that we didn't get to. And then we'll be moving to sine and cosine graphs with an activity. Okay, so on the notes, we're going to take some notes about arc length, and then we're going to discover something about sine and cosine with our activity. What is the relationship of sine and cosine graphs to the unit circle? Explain in detail. So first of all, I just want to clarify, because I didn't actually realize until last year. I always thought that this sign was called theta with an F. It's not true. I realized last year when I actually saw the spelling of the Greek word, it's theta with a TH. Okay, so that is theta. Okay. I mean, I've done, high school math, college math, and I got a master's in math, and I just never knew it was theta. I always thought it was theta. And then last year, I saw it in the book, I was like, oh, theta. Okay, so TH, so let's make sure we're pronouncing it correctly. Theta. Theta represents the angle. And for arc length happens when we have a circle. Okay, let's write down arc length. And what arc length is pretty self-explanatory. It's the length of an arc on the circle. Okay, so let's do our best to draw a circle. That wasn't too bad. Adam, please take the earbud out. Draw a circle, please. All right, in a circle, from the center to the edge of the circle, Gentry, what's that called? A radius, good. So we're going to mark it R. And if we have two radii, kind of making it look like Pac-Man, it creates an angle inside of the circle. And so the measurement of that angle is theta. 2 radii. Okay, and these radii create what's called an intersected arc from here to here. And the length of that intersected arc is the arc length. So let's write down what arc length is. When 2 radii, double I, radii form an intersected arc. Guys, all this talking needs to be more writing. 2 radii form an intersected arc on the circle. Okay, and the length of that arc is called arc length. Okay, we have 2 radii that form an intersected arc on the circle, and the length of that arc is radii. The formula to find the length is S. S is what we use for the arc length, equals R times theta. However, there's one catch with this formula. Theta must always be in radians. It doesn't work in degrees. So if you're given a degree, you have to convert it to a radian. Theta has to be in radians. Okay? So, for example 1, draw another circle. I cheated and already had one formed with the computer. And we're going to fill in pieces of the circle. And then use that information to find what's requested. So we have 3 inches here. Notice the arrow of the measurement of the arc, so we can see if it's positive or negative. 5 pi 6 2 pi thirds. We have a b out here and an s up here. I hope everyone has the formula now so I can scroll it up. Okay. The question for example 1 is, what is the length of arc B? Formula is S equals radius times theta. Okay? So using the formula, S equals radius times theta, let's find the length of B. Okay, Austin, what should we plug in for S? That's theta. So S is the arc itself. We have a labeling on the arc. What? Kind of a tricky question, because the arc isn't a number, is it? So what letter are we looking for? B, because right now there's 2 different arcs labeled. The one we're currently working with is B. Okay. Lisa, what's the radius? The radius starts at the center of the circle and goes out. No, that's the angle again. The radius starts at the center of the circle and goes out to the edge of the circle. There's 3 radii here. One of them's labeled. 3. Because all radii are congruent in the same circle, right? So even though the other radius is labeled, they're all 3. Okay, and we've answered this one a few times already. Theta. Nathan, what's theta for the arc we're looking for, which is B from here all the way to here? 2 pi over 3. All right, this formula works if our theta is in radians. Forrest, is our theta in radians? Yeah, if we have the pi, then we're in radians. If we have a degree symbol, then we're in degrees. Okay, so without calculators, we can calculate this. D? D? Okay, yes, we can cancel 3s. That's a good idea. And then we are left with 2 pi. Now the directions actually ask us to round to the nearest tenth. And we actually discovered what 2 pi was last time, so we can do it without a calculator. Put calculators down. 1 pi is what decimal, approximately? 1 pi is 3.14, approximately. So 2 pi was approximately 14 doubled. Would be 28. Yes. Okay, so rounding, no, it's not. Rounding 6.28 to the nearest tenth. To the nearest tenth, 6.28. See that? So it'd be 6.3, and now we need a unit. Okay, Nathan, what's the unit of the length? Great. You see the unit actually on the radius right here, inches. It's not inches squared, it's not inches cubed, because the length, if you think of like the Earth, we're currently on a sphere, right? And when we go walk outside on the flat ground, we're actually, even though we don't feel it, we're actually walking an arc.
That's so scary. What is like
That's why we have gravity that keeps us on Earth. Okay, and when we walk on the flat ground, we're really just walking one direction. It's not until we find area that we get inches squared, because then you'll have a length and a height. But length is just one direction, so it's just inches. Styles?
Flat.
I know, I said flat ground, but you know, to our eye it looks flat, but when we're actually walking, it's a microscopically curved arc.
So if I throw a microscope, I can see it.
Yeah.
Maybe. If you go out and sit on the moon, you would see that the Earth is curved. Or we look at the moon, right, and we can see that it's a circle. It looks two-dimensional.
Alright, so I'm gonna become an astronaut.
Go live on Mars. People are going to go live on Mars in a few years.
Yeah,
Really?
I heard that.
Yeah, I actually met a guy, not met, I walked past a guy who was having a conversation in the same social group setting, that he was one of the applicants who's been selected to go to Mars.
Why though? Just because?
Make history. Go live the rest of your life on Mars.
Wait, but I have a question. Is there like aliens up there? No.
Guess we'll find out. But the deal is, it's a one-way ticket, and you won't be coming back. Ever.
Why? Let my family die.
Okay.
And then...
Let's do another one, please.
Because there's no way back.
Okay, we're doing another one, please. Cassie, put that away, please. Example 2. The question is, nope. What would happen to the arc length? What would happen to the arc length if the radius was doubled? What would happen to the arc length if the radius was doubled? I'd like you to calculate that and then make an observation, please. What would happen? Same picture. It's still going off of that circle. Okay. What would happen to the arc length if the radius was doubled? Okay. Calculate it out and make an observation, please. I put doubled. Yeah. You know what? That happened yesterday too. Apparently, I closed my U's. Better? Okay. Please calculate it out and make an observation. What happens to the arc length when the radius is doubled?
What y'all do?
Come on, Adam, you have something to do. Work on it, please. Styles. Come on. Everyone's calculating. What's going to happen to the arc length if the radius is doubled? Yeah. Okay. Calculate it out and write down your observation. Calculate it and then write down your observation. Styles. Did you guys calculate it?
Yeah.
Okay, did you write down an observation?
Yeah. But I don't try.
Let me see. What is this?
I don't know what's called.
What's the title of the notes? Yeah. You need to put some vocabulary in that explanation. So, if we double the radius, it would be at 6, correct? Does theta change?
No.
No. Okay, so who has their observation that they're going to share? Cassie, what'd you get? No, I think you're doing a little more work than you need. I do see some simplification. Cassie? Cassie, with 6 on top and 3 in the denominator, what can we divide into both 6 and 3? 3, yeah. So 3 divided by 3 cancels to 1, right? And 6 divided by 3 becomes 2. So we shouldn't get 9 pi, it's actually 4 pi. I think you were like trying to use inverse operations to solve like side to side, and it's a little too much work. So we need to calculate 4 pi. Does anyone over here have the calculation for 4 pi? 12 point, I think it would be 6. Okay, so we get 12.6 inches. So this was originally it was 6.3, now it's 12.6. So who has an observation of what happens to the arc length when the radius is doubled? Eric? Okay. Because what happens to the arc length? It doubles. When the radius doubles, the arc length also doubles. So that's our answer. When the radius doubles, also doubles. This is your answer. Please write it down. Okay, you two ladies are also about ready to get a new seating chart. Yes, Stas?
At first, I got like 18 point.
Maybe you didn't use parentheses on the fraction?
I accidentally did 6 times.
Okay. So, this is a key observation. If we have a circle, that's 2-dimensional. The arc length is 1-dimensional. So when a radius doubles, and we get 2r instead, it doubles, the arc length is also going to double. Because 1-dimensional, and when we double or if we triple, it's going to do the same thing to lengths. But if we switch over to area, and say this was our original circle, and then the radii was doubled, the area, this actually goes back to secondary math 2, just as an observation. The radius on the length was doubled. The lengths double. But that doesn't happen in area. Okay, again, if the radius is doubled, the area does not double. Okay, instead, so if the original radius, well, was 3, right, and then the new radius is 6, the original area, what's the formula for area? On a square, yeah, or a rectangle, that would work, but for a circle, yes, pi r squared. So this would be pi times 3 squared, which is 9 pi. And then the doubled one is not 9 pi. Do you think it's going to be 18 pi? Pi times 6 squared. 6 squared. Amy, what's 6 squared? $36 pi. So you can see that the areas do not double. Instead, what do the areas do? Yep, that's exactly right. Can you say that louder, please? Quadruple. 9 times 4, is that 36? Yes. So that's off of our scale factor with area. If you take the scale factor and square it, in our case, if the radius was getting 2 times larger, so our scale factor is 2 squared, we get 4, which means the area quadruples. if, say, our radius got 3 times larger, it's not going to quadruple anymore. What's 3 squared? 9, so we get 9 times larger. Then if we move into 3 dimensions with volume, okay, so I'm going to draw a sphere. Here's our original 3, and then, oh goodness, I can't draw. And then it turns to 6. Volume is not going to, if the radius is double, volume is going to, instead of squaring, same idea, but volume's not squared, is it? Yeah, the 3 cubed. So if our scale factor is, it gets twice as large, our scale factor is 2 cubed. 2 cubed, 2 times 2 times 2 is what number?
8.
8. So the volume is going to get 8 times larger. So it depends what dimension you're in. Arc length is 1 dimension. If the radius doubles, the lengths double. The area is in 2 dimensions. If the radius doubles, the area does not double, it actually quadruples. It becomes 2 squared. And volume is in 3 dimensions. The radius doubles, the volume doesn't double, it becomes 2 to the 3rd power, so that would be 8 times larger. Okay, the last thing we're going to do is a story problem. Please write down the important information as I read. Okay, this I believe is example 3, correct? Okay, write down the important information as I read. Suppose a satellite orbits 3,600 kilometers above Earth's surface. You should be writing down important information as I read. Example 3. Suppose a satellite orbits 3,600 kilometers above Earth's surface and completed an orbit every 4 hours. How far would the satellite have traveled in 1 hour? Suppose the satellite orbits 3,600 kilometers above Earth's surface and completed an orbit every 4 hours. How far would the satellite have traveled in 1 hour? Okay. Chiz, what did you write down? What about every 4 hours? So 1 orbit is completed in 4 hours. Good. Okay. Christian, did you get something? 3,600. Okay, what does 3,600 kilometers represent? Not velocity. How high above Earth it's orbiting. Okay, so 3,600 kilometers above Earth's surface. Hey, Haley, did you write down your homework? Oh, here's your homework, Haley.
Homework?
Okay. Okay, this is the orbit. And lastly, there was a question. Joseph, did you get the question? Ariana, did you get the question?
Something, how much of a velocity?
No, not anything about velocity, actually. Eric?
How much does it complete in 1 hour?
Okay, we're getting warmer. Something about 1 hour. Not how much is it complete, but how the distance traveled after 1 hour? Okay. How far? Velocity is speed, guys, so it's not talking about anything about speed. Far after 1 hour. Okay, so a picture would be a great way. There's going to be a couple homework problems just like this. Hint, hint, hint. A picture would be a great way to visualize what's going on. So the center of your circle is going to be Earth. Okay, you know you have some continents in here. And then you have some water. Okay, and orbiting around Earth, we have a satellite.
It's the moon. Yeah, that's the other
Okay, notice the orbit, is it rectangular? No. The orbit would be circular. And it tells you the radius, which is the distance from the surface. Kilometers. Okay? Now it says one full rotation takes 4 hours. Please tell me when to stop when I've hit 1 hour.
Stop.
Good. What angle is that? What's theta? Yes, you should draw it. 90 degrees. And we can figure that out because one full rotation is 360 degrees. Divide that by the 4 hours. Means every 1 hour would equal 90 degrees. Okay, so using our formula, we can find the arc length, which is the distance that the satellite has traveled. S equals radius times theta. However, theta has to be in radians. Look at your unit circle, 90 degrees. Raise your hand. Don't shout it out, please. Raise your hand when you know 90 degrees in radians. Thanks for raising hands. Raise your hand when you know 90 degrees in radians. Okay, Noah? Pi over 2, exactly. Thank you. So, here's our radius times pi over 2. I notice the 2 and the 3,600 are both even, so we can simplify. 2 cancels out. 36 divided by 2 I know is 18. So 1,800 pi. Okay, type that in. Raise your hand when you have the rounded decimal. Let's round this to the hundredth. Rounded decimal with a unit for 1,800 pi to the nearest hundredth. Round to the nearest hundredth. Okay, and what'd you get?
5,654.86.
0.8, but after the 6 comes another 6, so rounding, we would go 8. 5 or more up to the score, 4 or less, let it rest. So 0.87. And then our unit is right here, kilometers. Okay? So you have a short book assignment out of this, and then we'll be doing an activity which we'll be expanding upon more next time. The short assignment from radians is just pretty much the problems we didn't do on our last assignment. 5 through 13 and number 18. Okay, so that's only 10 problems, I think, but they go really fast.